Hello guys, welcome to Inside Electronics. So I was actually trying to repair one of these glass broken LED lamps. Actually this was in my living room and it just fell down because I was removing the webs from the roof, and unfortunately this thing fallen down from the socket, and there was a glass covering over this with the diffuser element built inside of it. It was actually full glass element with the kind of phosphorus coating type diffuser element, not any plastic one. So the glass just broke away, and this is what is inside of it. And the reason why I'm shooting this video is because this is actually a working LED. I'm not going to open this, but I'm going to troubleshoot this LED lamp, because right now at the moment only half of the LEDs are glowing. I mean, if you consider this as a set of LEDs, it's actually a series of two parallel combinations, like two set of LEDs that are in parallel and are also in series. So that's how this thing is arranged. So initially when I got it, I made a simple modification over here before starting this video. When I got this thing opened, and what happened is that actually nothing, it was actually flickering. The LEDs are just glowing rapidly, and that is because of this track over here. There is a slight cut over here, so I just removed the entire track and soldered a good piece of wire on there. That solved the flickering problem, but now only half of the LEDs are glowing. Let me show you that. This is not a Chinese made. This is G Light branded 10 watts 6500 Kelvin, that is the cold white, and this is made in India itself. It's actually a really good one. You can see the heatsink, and it feels heavy also. Without this it feels really heavy. The heatsink is actually an aluminum piece that shaped, and the LED stickers are sticked over the Captain tape over here. So anyways, let me just zoom back a little bit. Oops. So if I plug this in, let me show you this. If I plug this in and turn it on, nothing. Oh, there it goes. So if it's kind of loose in this one. So if you look, you can see that this side is not lighting at all. Only the other side is, this side is lighting up. So I want to know why is that happening, if there is any short circuit or anything inside. So I'm just going to turn this off, and I don't have anything right now other than a pen. I just want to short circuit these two terminals. Okay, since I don't exactly know whether this uses a capacitive dropper or the switching LED driver, dedicated LED drivers, but I'm not going to open it any further. What I'm going to do now is I'm going to troubleshoot this LED. Because all these LEDs are connected in series, I assume that one or more LEDs are broken somehow, and because of the broken LEDs the current cannot complete, and that's why this thing is not lighting up. On the other half, everything is working fine. So one series string is fine, the other string is not working properly. Let me draw it. If you haven't understand, this is how it all works. This is the, let me zoom in. This is the first row of LEDs, and this is the second row of LEDs. So this is how this is all connected up. And now let's assume this string is okay, this string is faulty. So I want to know what is wrong. So what I'm going to do is I'm going to check for the continuity of the LEDs. Right now the meter is having some issues. Okay, so I'm going to check for the continuity, and I will actually, this is a section that is not working. So let's actually check whether this thing lights up. See, if you look carefully, you can see the LED glows. So that is fine, that LED is fine, that is fine, and now I have to check each and every LED in the string. So I'll be back once that is done. So okay guys, I found the bad LED in this one. It is this LED over here. So if I connect it, nothing is happening, but every other LEDs in that connection are working without any issues at all. So that is the bad LED. So you can see everything else is working except this one LED. I checked every single LED and this is the only one that is not working. So let's see if I short that out whether it lights up. So just wait for a moment. So I'm going to short out this rogue LED and I'm using the current mode. If you can see the meter, if you look here, you can actually see how much current is flowing through each LED. I'm going to short this LED and see. That's it lights up, and as you can see it is taking around 58 milliamps. Okay, so now I have made a short circuit across that bad LED, and for this purpose I use my variety SMD soldering iron, which I made a review about it, complete review. You can watch it by clicking the I button right there. So now let's test it out. So I'm just going to move my soldering iron away from the frame and let's just bring it back. Now when I should test it, it should light everything up. Oops. And there it is. Every single one of them is lighting up. So I fixed it. Anyways, thanks for watching. See you in another video. But before that, let me measure the current flow through this LED set again, because now since I shorted it, the current flow must be increased. So I want to know what is the current flow now. Wait a moment. So if I now short circuit the LEDs, it should measure around, it is measuring around 68 milliamps. That is actually, that's an increased current flow. So I don't know how long these LEDs are going to suffer from that, because since it has that efficient heat sink, I don't think it will be a problem. But anyways, I fixed it. Thanks for watching. See you in another video.